All right, we're going to take a look at function notation. F of x and y are the same things. You put an x in the domain into the equation, and you get a y value. That's how we crank those out. So here we're going to start doing what we call composition. We're going to do a combination of functions. So suppose g is described by doing the following steps. Add 4, multiply by 3. Okay, determine g of 5 and find an expression for g of x. Let's do g of x first. Okay, we're going to start with some kind of an x. And then what are they asking us to do in part 1? Add 4. Then, once we've done that, what are they asking us to do? Multiply by 3. So do you just go times 3? No, why not? Because these guys are happening first, and then this is happening second. So this is going to make things a little different than just x plus 12. It's going to be 3 times x plus 12. So now we can look at g of 5, and what do you get? Well, put a 5 here, you'll get 20 times 3 is 60. Feeling good about that? I don't know. I think you should try it for you. Okay, up on the board here, I have an easy question for you. What is the difference between this first one and the second one? And I'll be interested in what your answer is. Everyone has to answer, and so what you're going to do is the person in front or behind you, you're going to tell them what the difference between those two, if any. Yeah, so for the first one, or the second one, I found the x-intercepts, like I did, and then I made a parabola because I knew it was going to be a parabola, because you're going to get x squared minus 4x, right? That's going to be a parabola. And it goes through those points. That looks good. But this one, what values make it true? 4 and 0. No kidding, that's what the graph looks like. So if you see y equal x minus 4 times x, everybody put your arms up, parabola, y equals. And if it's equal to 0, what is it? 2 points. Go like this, 2 points. So if you set this equal to 0, 2 points. If it's equal to y, it's a whole function. These are very different. This is any y, and this is y equal to what? 0. So do you see why this one will give you all of these values? It's any y. This is only the places where y equals 0. Now, does that make sense? So show me again, f of x equals x minus 4 with your arms. Show me equal to 0. You can make the sound effect if you want, but these are different. Love that. And there's a whole bunch of functions here that you probably know. We call these the basic functions. Here are the ones I'd like you to know just in your brain to be able to sketch. Y equal x, y equal x squared. And we'll do this with our arms. Y equal x, y equal to x squared. The cubic is going to be this one, y equal x cubed. The reciprocal, that's what I call the butterfly. Goes like this. We'll have the square root. I call that the elephant trunk. Goes up like this. Exponential we'll work on. Natural log we'll work on. Don't worry about these two for a while. Sine curve will be later this year. Cosine. Absolute value we'll do right away. Would you show me x squared with your arms? Y equal x squared. What's y equal to absolute value of x? Straighten V shape. Good. And greatest integer we'll work on. Logistic we'll work on. So those are the basic trig functions that we're going to be working on. Now, I told you at the beginning of the hour that I have a cure. All right, so I told you at the beginning of the hour I have a cure for every disease. Malaria, AIDS, you name it, I can cure it. Did you know that? It's real simple. It's a bottle of drain cleaner, liquid plumber, because it'll kill every disease. Please don't ever drink liquid plumber, by the way. Don't ever drink anything that's toxic. What would happen to the disease if I gave you a drain cleaner? Would it kill the disease? Yeah. There's only one problem with my cure. Oh, it kills you too. And that's a nice little segue into what we're going to be doing is finding the implied domain. Is you can put a 0 into anything, but sometimes it's going to be undefined, and you can't just put in any number you want. Just like you can't use drain cleaner to cure every disease. And you're going to learn a bunch of these. These are the ones that we're going to work on, and we're going to start easy, and then we're going to work our way up. For the first one, you could say that the domain of this is all real numbers, but there's one that's a problem. So we would say x is an element of the real numbers, but there's one we can't have here. What is it? A 0. Because if you put a 0 in, it's going to be undefined. You could say, well, wait a minute. Can't I just say it's 3x times x over x and cancel those out? Yeah, you can. But the problem with that is when I put it into the original function, it's still going to be undefined. So we would say the domain of this is all reals except 0. One way of looking at this is called implied domain, is that you don't have to be told this. You can check set, number 1, set denominator equal to 0. Oh, you're going to get so good at these. Next. Ooh, this one's crazy. What values for x can't I have? This will be all reals. So the domain of this one's going to be x is an element of all the reals, but you can't have what? I'm not sure about 0. We'll check 0. But what happens if I put in a 3? You're going to get 4x over 0, and this will be a problem. So 3 is one you can't have, but there's one more you can't have. And if you put a 0 here, what's 2 over 1 minus 0 over negative 3? Well, 0 over negative 3 is 0. What's 2 over 1 minus 0? 2 over 1 minus 0. Is that that's 2. Is that a legal answer? Yeah, so 0 isn't a bad one. There is a bad value that we can't have. Anybody know what it is? It's tricky. We're going to set this whole thing here equals 0. Well, we set that first one equals 0, and then I'm going to set 1 minus 4x over x minus 3 equal to 0. So 1 is equal to 4x over x minus 3. Cross multiply, you get x minus 3 equal 4x, and you're going to get negative 3 is equal to 3x. So what's x equal to? Negative 1. So if I put in a negative 1 here, I'm going to get negative 4 over negative 4. What's negative 4 over negative 4? 1. What's 1 minus 1? So that's why you can't have it. So implied domain, one thing you can't do is you're just going to find what you can't do, set the denominator equal to 0. And that's what we did there. There's another one that's a problem, and that is we can't take the square root of a negative number. You can't take the square root of negative 2. Try it in your calculator. If you don't believe me, it'll say error. So if you can't take the square root of a negative number, then anything inside the square root needs to be what? If it can't be negative, it has to be greater than 0. Or equal to 0. That'll work too. Okay? So this step 2 is set whatever's in the function f of x to be greater than or equal to 0. If you have a function in a square root, you set that greater than or equal to 0. So in this case, my domain is going to be all x, I better check this out, minus 3x greater than or equal to 0. How would I solve that? add 3x to both sides. So 4 is greater than or equal to 3x. What's x going to be less than or equal to then? 4/3. You got it. So this is my domain, x less than or equal to 4/3. It can be equal to 0. The square root of that can be equal to 0. So those are the two. Now, would you, oh my goodness, you could do 2, put them both in there? That would be crazy. Now we can do both of them. Step 1, set denominator equal to 0. Step 2, set the function equal to 0. So we have, in step 2, we can have 2x plus 1 greater than or equal to 0. And what can't you have? X squared minus 1 can't be equal to what? X squared minus 1. What can't it be equal to? 0. So this is going to be x equal to plus and minus 1. This is going to be 2x greater than or equal to negative 1, x greater than or equal to negative 1/2. So the domain of this guy is going to be all of those x greater than or equal to negative 1/2, but you can't have what? Can't have 1. All right, here's your assignment for tomorrow. Go way down to day 1, and all I want you to do for tomorrow are these and those. Wow, was that perfect time?